Pre-AP Pre-Calculus. Here is your first video of Pre-Calculus. We're in section 1.1.1. First thing I want to point out, you're going to notice at the top of each section these boxes. And so these boxes here are your learning targets. In other words, if you can do what it says in the box, then you're going to be good for the test. So if you notice in Canvas, and hopefully I've already pointed this out to you, but in Canvas at the beginning of each module, it's going to say the learning targets for the module. If you can do everything that's on that sheet, every learning target for that test, you should be able to ace the test. So it's just kind of like your roadmap of what I need to do to prepare for my test. If you come to one of these boxes and you don't understand what it's saying, or you don't know how to do that piece, that's what you need to come to tutorials and get help on. So this says we can describe subsets of the real number system using set builder notation, and we can describe subsets of the real number system using interval notation. Well, that's great, but you're probably saying, well, what's the real number system? And that's just the system of numbers in which we operate. We call it the real numbers, and you may have heard teachers fling that out, but we may never have really explained what the real number system is. If you have seen it, hopefully this is a great review. And if you haven't seen it, we're going to go through it now. So the smallest set of numbers that we know are called the natural numbers. Okay, and that's the smallest numbers. And these numbers are 1, 2, 3, 4. Sometimes you hear them called the counting numbers, but in our book they call them the natural numbers. And we denote the natural numbers with this bold-faced N. Sometimes you see it written like that. It's kind of like a capital N type, some sort of funky type. Sometimes I've seen it where it's bold on the left-hand side, and sometimes the slant of the N is bold. Either way, that's a capital N in the fancy set type, and it stands for, the natural numbers. Natural numbers are the things that you can count on your fingers, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, all the way on to infinity. Those are our natural numbers. Now, if we add one number to the set of natural numbers, we get what's called the whole numbers. And the whole numbers, any guesses as to what you add to 1, 2, 3, 4, 5, 6, da, 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 da? Anyone say 0? If you did, you're absolutely right. So the whole numbers is the set of numbers 0, 1, 2, 3, dot, 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 all the way on up to infinity. What aren't we including in here? These are just the numbers we can count on our fingers. So we're not including halves, we're not including thirds, we're not including any sort of weird, funky stuff like irrational numbers, square root numbers, pi. That's not included. Just the things that I can count on my fingers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to infinity, and 0. These are called the whole numbers, and we denote the whole numbers with a bold-faced W. And again, I've seen it bolded in a couple different ways, like that. I've seen the first part of the W bolded. But as long as you've got something bolded in there, we can get the idea that that's the whole numbers. All right, any guesses as to what we would include in the next subset of numbers? So if we add something to our whole numbers, we get to our next set of numbers. Maybe you've guessed, well, what if we add in negative numbers? So if we include all the way to negative infinity, up to, say, -3, -2, -1, and then up to positive infinity. Again, notice I'm not including fractions, I'm not including anything funky, just negative numbers, 0, positive numbers, things that I can count on my fingers, positive and negative things I can count on my fingers. These are called integers. Now, what do you think we denote integers with? How many people said I? You are wrong. We denote this with Z, and you're like, why Z, Miss Harris? That makes no sense. You're going to see what we use I for in a second. You actually know the answer to that question. So you might think about it, you might be able to come up with it. So those are our integers. So negative numbers, positive numbers, all counting numbers, and including 0. And then the last part on this side of our graph, we're going to actually add in all those fractions. So a half, a third, a fourth. These guys are called rational numbers. Rational numbers could be a half, it could be a third. It could be anything that has a decimal that does not go on forever. So 1.56. That's a rational number. I can express that as 156 hundredths. So if you can express the number as a fraction, then it is a rational number. Rational, you can remember that one, that's ratio. Ratios are fractions. So it could be a fraction form, it can be a decimal form, as long as you can write it as a decimal that does not repeat and stops. So a truncated, not truncated, but a decimal that stops there. Those are your rational numbers. What do you think you use for rational numbers? How many people said R? You are not correct. We use Q for rational numbers, and they bold it by putting like a straight line down there. Again, you're going to see in just a second why we don't call that R. Okay, so all those are our rational numbers. So rational numbers are just not just fractions. Remember, rational numbers are also everything that's in here. So we start with natural numbers, 1, 2, 3, 4, 5. We add 0 to get to whole. We add negatives to get to integers. We add fractions into this mix. So anything that comes in between these guys that is a fraction now is considered a rational number. So that is one piece of our real number system. The other piece is called, what's the opposite of rational? You learned about them last year. They're called irrational numbers. What's an example of an irrational number? An irrational number is something like the square root of 2. This number is 1.2 ... Goes on. It keeps going on and on forever. Trying to think, what else? The square root of 3, the square root of 5, square root of 3 would be 1.73205 ... That is what they include, or that's the example they have in the book. Other examples of rational numbers would be, what's another number you know that goes on and on forever? Hopefully some of you guys are thinking, well, there's pi. And you learned about pi in geometry, or maybe back in middle school, I'm not sure which. And then you also learned about one last year. Towards the end of the year, we learned about this guy called E, right? And remember, E is I might get this wrong, but 2.718 ... something along those lines. So those are all irrational numbers, and we denote irrational numbers with a bold-faced I. So the I goes to irrational, does not go with integers. Tricky, tricky. And remember, the other thing that we talked about was that R. Well, we don't use R for rational. We use R to denote real numbers. So if we say that X is a real number, then it's anything that's rational or irrational. That's all the numbers we can think of. Well, almost. We also learned about one other set last year in Algebra 2. There were real numbers, and what was the opposite of real numbers? Anybody remember? We talked about imaginary numbers, right? So imaginary numbers do not live in the real number system. So if I give you a number, say like 2 plus I, and I ask you which of these subsets it lives in, you should say, Ms. Harris, it's not a real number, so it's in none of these sets. All right, so that is the real number system. I'm going to go ahead and stop the video here. We'll do some definitions on the next video, and we'll talk about set builder notation, and we'll write some of those, and then we'll talk about interval notation, and we'll write some examples of that.